All right. Just so you know, I'm recording the whole class. So if you guys are misbehaving, that'd be sad. People might hear that. Okay. Now that we can estimate the field of view, we can use that information to actually measure the size of a specimen. So we'll practice with that today. So in our notes, we're going to do an on-paper practice, and then we'll do the microscope practice. So there's two methods. They're actually very similar. I do want Chromebooks at least halfway closed. If you have them open for a calculator, that's fine. But definitely focusing up here right now, please. So for this, we have a question here. We've got an amoeba underneath our microscope, and we want to know how big is that amoeba. So in order to estimate its size, you need the field of view, and we can find that through either calculating it with a ruler and or using the formula that we just practiced. So how do we use that information to actually find the size of the organism? All right, go to the next one. Okay, so here's kind of the protocol. First, you figure out what is it we're trying to measure. So if I'm trying to measure this clump of cells in the circle here, we need to figure out, first of all, what's our field of view. And then we need to figure out basically how much of that field of view does that clump of cells take up. So you can think about this in two different ways. So first, you're going to estimate the fraction of the field of view. So to imagine that, you can actually draw circles if you have like a picture, like in your notes, or you can just kind of try to imagine. So if I take this clump of cells that's that size, I imagine how many could fit in there, right? So how many orange circles are there? 10. So about 1/10 of that field of view is taken up by that circle, right? By that clump of cells. So that's our first step. That clump of cells we're trying to measure takes up about 1/10 of the field of view. Then we multiply the field of view diameter by that fraction, right? So we know if it's 400 micrometers, we want 1/10 of that, 1/10 of 400, right? So 400 times 1/10 gives us 40 micrometers. All right, I'm gonna let that sink in first. We know our field of view, and we know that our clump of cells takes up about 1/10 of that field of view. Notice also we're only measuring the diameter. It would be much more difficult to measure like the circumference. So usually we just measure the diameter, the length or the width. Okay, let's try this. Go ahead, go to the next slide. So you should have this in your notes. You see these two pictures? We're going to do the one on the left. Okay, next slide. Okay, first of all, we need to go backwards. The first thing we need to figure out is our field of view at 100x. This is just like our warm-up. First, we need to figure out our field of view at low power. I know this is a very blurry ruler, but do your best. And I know this is a square, which is not usual for a microscope, but it's okay. Pretend we have a square microscope. So what is our field of view at low power? How do we find that out? By counting the ruler. Goes to 90. We want the whole field of view. Not just this yet. We need the whole field of view. We want to go with 90? Okay, let's do 90. If you did 91, that's probably fine too. So our field of view at low power is 90 what? Millimeters. Okay. What's our magnification at low power? Okay. What's our magnification at high power? 100. Okay. So what's this answer? So 9 times 2 is 18. So 180.
180 divided by 18.
Maybe 1.8.
Yeah, 1.8.
Yes?
Yeah.
Okay. So put 1.8 in your notes under number 1. Is that what my next slide says? Keep going. Keep going. Oh, I did 92.
Oh.
So then it came out to 18.4. Oh, you were right. Is it because it's not 180, it's 1800? Okay. So we got 18. You could stick with 18.
Oh, it is 18.
If you did 91, you would have got a different answer. If you did 92, you would have got a different. Okay. So remember, if these are written answers on your test, which they will be, they won't be multiple choice, as long as you're close. Okay, I'll have a range. You're within this number to this number, you got it right. Okay, so we did our first step. So the next step, estimate the fraction of field of view. So I've drawn you one circle. I want us to measure this one cell. So if you want to draw circles on your notes, I need to know about how many circles fit in that space, in that field of view. It's hard to imagine. It's a little easier if you draw.
10.
Try to keep drawing the circles. Yes. 10. Okay. Also, you guys can do fractions of circles. It doesn't have to be a whole number. Let's see what I did. All right. So for me, it was kind of easy. I just copy paste. So how many do I have about? I have 10, but then this one and this one on the end are not really full. So if we add this part of a circle plus this part of a circle, I would say 11. I think we go with 11. Or anywhere, if you want to do 11.1, that's up to you, whatever you estimate. So what fraction of the field of view does our cell take up?
1/11.
1/11. Okay. So then what do? Okay, good. So we take our field of view times the fraction of what our cell actually takes up, 1/11. So your field of view, whichever you guys decided with that, I'm going to go with what we have on the board, which is 18. So yeah, so 18/11 and what? You can go forward on the board. That'll tell us that answer. So then we just
1.67.
yeah, so close, right? If we did 18.4, it'd be 1.67. We did 18, it'd be 1.64. All right, and that is in millimeters. So what's our answer in micrometers?
164.
Good, 164 or 167, whatever you're going.
Or it's 1,000. 1,000.
Oh, you're right. It's Monday morning. That's what's wrong with me. I'm so sleepy today. Okay. Very good, very good. All right, I'm going to give you guys a moment to do your next practice on your own. And then while you're doing that, I'm going to get out microscopes. Yes. So confident how to do what we just did on the board.
Yeah.
Well, if you wanted the actual size of the organism, yeah, because I was just showing that so you can like this is what I'm doing. But you should be doing.
I say that's 2.5.
Sorry, like,
Wait.
can we move this table like we did before, guys?
Hey.
Oh. Oh, I just noticed they gave me a Chromebook. That says teacher. I bet this is for.
Wait, how do you?
I'm really smart sometimes. Thank you.
You have a decimal. Oh.
I'm getting on my
Like if you're like, oh, it takes up 1.5. 1 over 1.5. All right, let's go next. Let's step it out with the mouse for a little bit. Just the first step. Oh, we're gonna skip that because that's not in your notes. Skip, skip, skip. Okay, Silver, that one's not in your notes either. Oh, that's a practice. Skip, skip, skip. Okay, here we go. Did I do the answer? Keep going. No, I didn't. Okay. Well, just leave it there, I guess. Okay, so first step, we needed to figure out what the FOV at. Yes, but in order to get that, we need the field of view at low power, right? So our field of view at low power would be definitely more than 70. I'll go 73. So 73 millimeters times 100
Over 500.
or 500. Okay. That's. Are you doing this right?
I believe so.
You did 73? Is this close to what you guys got for
Yeah, that's
field
what
of
I
view at
got.
low power?
Yeah, a little
Yes?
bit.
Yes? Okay. All right. So our field of view at low power was 14.6. Cool.
Yeah.
Okay. So our next step is to find what?
Circle, how many circles?
Yes. So we have 14.6 millimeters. Sorry, that's a high polish. I lied. Okay. How many circles? So I was busy with Microscope. So my question is, did you guys make your circles as big as the red circle?
Yeah. About 2.5.
Okay. So that was, I realized it's kind of confusing on my part because really what I wanted you to do is just this part right here.
Oh.
But if you did the big red circle, you're still doing this the right process. So it's more about the process. Okay. So how many did we get that would fit? What did you guys get?
Circle 2.1.
So 2.5 red circles. Okay, so we'll do that in red. What did you guys get if you just measured the smaller, the actual clump of cells? Do that blue. Nope, I'll do that in. You said 3?
I'd say 3.2.
Okay, I can't really draw, but there would at least be like 1, 2, 3.
3.3, 3.4.
I might even say 4, almost 4 maybe. What? Because it's not plugged in. 1. I'll go with 3. Did somebody say 3.5? I'll go with 3.5. So we're doing 2 options here. So if you measured the red circle, you would have had your field of view at 14.6 times what's our fraction? 1 over 2.5. Okay, so 14.6 divided by 2.5 is 5.84. Units? Millimeters, good. And that would also equal. Perfect. That's if you did the red circle size. Okay. We did the smaller section, which is what I wanted, but I didn't make it clear. We would do, well, this was our fraction, right? So we would still start with 14.6. We're doing our field of view times, what's our fraction? 1 over 3.5. Okay, so what's that? 14.6 divided by 3.5? Is that what we did here? 1.7? Okay. In micrometers? Good. It's 1 over because we measured that 3.5 would fit, right? If I had 3.5, they would fit this way. But we only want to measure one of them. That's why we measure 1 over 3.5. Because we want that fraction of the whole field of view. Okay. So the next thing we're going to do is we'll get microscopes out. Half of you guys will use them, and then the other half will have to switch off, right? So what I would suggest we do is I will get out some slides. You can pick a slide, focus on it. Okay, remember to stop. Well, we all know our field of view at low power, right? We did that last time. Okay. So then zoom in to one of the higher powers, whichever one you choose, and find something that you're going to try to measure. Okay, and you're going to do the same process. I'm going to bring you paper because I want you guys to actually work it out and show me what you've done. So like, let me give you an example. So on a piece of paper, it'll probably just be like a little half sheet of paper or scratch sheet of paper. You'll put your name or your names if you want to work as partners, that's fine. You'll have a drawing, and maybe you want to measure this cell that looks like a star. Okay, so you're gonna just draw it. Doesn't have to be beautiful. Okay, just give me a little sketch of what you are looking at, what you're drawing, what you're measuring. Then show out your work, right? Give me the field of view at low power, field of view at high power, your mags, and give me the diameter of your cell or your piece or whatever it is you're measuring in millimeters and in micrometers. Okay, and then show your work so I can see what you're doing. Okay, it doesn't have to be whatever format you want to use, but that's kind of the basic info I'd like to see. Does that make sense? Okay. Now I'm just gonna bring some scratch paper out. I just want to see you guys doing work. Okay, go ahead, grab microscopes. Bring them to your desks. We'll get as many people working. You might need to reference it to know how to do the work on the microscope. But actually, I think I am going to have you guys switch off on doing notes. So if you're not doing microscopes, you'll be doing. Especially regarding microscopes. What are you doing in public? Okay. Nice. I have a whole inch. Yeah, we can if you want. Do you think we should show that right now? Yeah. Okay. Just so I know that's how to. Yeah, we could put it up for The only thing is I'm sharing my screen on Zoom.
I can send it to you.
You just send it to me and we'll open it up.
It just takes a while to load because there's a whole bunch of them.
That's all right.
Because I'm going to show my freshmen. Because for the ones that are online, they could just do this instead.
Yeah.
They can still fill out the worksheet.
All right, so we're actually gonna have a little video for you guys. Little how to use Microscope video. So in the meantime,
Let me open it.
I should probably get out my slides.
Where's your email?
Oh.
Someone joining IBY1 Zoom.
Yeah, that's me.
Oh, the partner and the back.
Let it load. It's gonna take a while. Don't know where the
Can I do notes first?
Stop hogging all the cords. I need you.
We actually are gonna be doing like a video thing, but yeah, if you want to give us a call and have somebody else in there. As long as all microscopes are being used, whoever wants to go first, it's fine. We gotta move so much. All right, here are my slides. I'm gonna put the slides over here on this desk. I have 2 boxes of slides. I don't know if I told you guys this, but when you carry a slide, please pick it up by the sides. Okay? Please, everyone, look. I do not want you to put your fingerprints on the glass part. Okay? So you carry it from the sides like this. If you feel like you have fingerprints on a slide, or if you need to clean a lens on your microscope, I will also put some lens paper over here. You do not use your shirts or anything other than lens paper. Okay? So you can tear out a piece of lens paper and clean whatever you need to clean. Here's our lens paper. It's just like thin paper that will not scratch your microscope. Okay, but it will take away fingerprints and oils. Okay, are you going to do a microscope or not?
Okay, real quick, when you're using a microscope, right, you obviously start at the very lowest magnification level, that's at 4. Your slides will look really, really blurry, and that's okay. That's when you use the coarse adjustment, right? That's that big knob. And you can see it here. Once you start using that big knob, it'll get a little bit clearer, right? Once it's as clear as you can get, then you can move it to the next one. You can move it to the 10x. It'll again go back to being blurry a little bit once it loads. And then again, you could use your coarse just a little bit more. What it does basically, it just makes it a lot more focused. And then once you're at wherever you want, it's either 40 is the biggest one or the 100. Then you move to the 40 eventually. Then that's when you use your fine focus. There's no point in using the fine focus at your lower ones because it won't show anything. It's too far. But once you're at the biggest one, then you can start seeing cells or whatever you're looking at. So you'll always start at the 4x. You'll always start at the 4x and then you'll move with the coarse focus only. Once it's clear, move to the next one, clear that up again, and then move to the biggest one, and then you can use the fine focus. And then that's it. Pretty easy. So that's when you once you get to the microscope. Cool. Oh my God.
Here's to show your work once you find the slides are right behind you guys. Here's to your work. Once you find an organism, catch it, draw it, measure it. Yeah, pick one of these slides, Jim. Question, 1, 2.
receivers.
I have all the microscope. I only have 2 here. Who's using this one?
Let's hope.
Again? Here, you guys, you haven't even slide yet. I'm gonna kick you off microscope if you're not doing work. Right there. I know. You have 2. This. And then your little.
Can you try unplugging it?
This one? This one. Yours working?
Rock blood. I want that one.
Your light on?
This one's not even plugged in. I get something. I have frog blood right here, so. No, it's not.
You don't even have to plug. You don't have to plug.
Yay, mine
works.
works. Is that a green one?
Okay. I might just do a plug. Find a size. You want to open this? Put it inside that other middle part. So that's when you start messing with this. That one looks dirty. Let's clean it.
Did you have your plug? Okay.
Thursday, hopefully we're just studying for the test. If not, we might be finishing up notes lesson. Oh, is that day? So how come you won't be here? So it's that, oh, it's a lesson, not a test. Yeah, but the thing is, I can't here. Early. Yeah, I know. Because I understand if you have to work that early, but I don't know if you're gonna allow me to work because you're not here. I can ask, but they're probably gonna say no on that. But I'll ask. Huh? I'll ask, because even now, even the students who aren't here, the Zoom doesn't give them attendance. It just gives them support in getting the work done. Yeah, the Zoom doesn't give them attendance. It just helps so that they're more able to do the work that they missed. So attendance is only driven by work. So I will ask and see what our options are. When is this, Thursday?
Give me 1 second.
There's like way more than that, man. So,